And I'm back with another partial fraction decomposition example for you guys. So again, when we're decomposing partial fractions, we always want to make sure that our original rational expression is set up with linear factors in the denominator. And if you look at what we have here with x squared minus 4, that's not linear, that is quadratic. And we know it's quadratic because of the x squared. So before we can do anything to work on this problem, we need to make sure that we have that rational expression that we're starting with factored into linear quadratic factors. So x squared minus 4 is a difference of squares. So I'm going to rewrite this. 3x squared minus 11x minus 26. And that's going to be all over. We have x plus 2, x minus 2, x plus 1. So we need to have that so that everything is linear. Every x is to the first power, not squared. All right, so that's an important detail. And once we've done that one step at the beginning, then we can run through this and I can say, well, I have a over x plus 2 plus b over x minus 2 plus c over x plus 1. All right, so same problem like we just did, same as the other two examples. We just had to do that one step first, factoring. So in this situation, we're going to multiply by the LCD to clear the fractions. And I've got x plus 2, x minus 2, x plus 1 is my LCD. And I'm going to multiply that by 3x squared minus 11x minus 26 all over x plus 2, x minus 2, x plus 1. And then I'm going to multiply that LCD by each term. I'm going to have to write this on multiple lines here. So I've got x plus 2, x minus 2, x plus 1. We're going to multiply that by a over x plus 2 plus x plus 2, x minus 2, x plus 1 times b over x minus 2. And then the third term on the right, x plus 2, x minus 2, x plus 1 times c over x plus 1. And we do this because we get some canceling and all of my denominators should go away. So one of those LCD factors cancels in each of these, and what I'm left with is 3x squared, and I don't need the parentheses now on the left. So 3x squared minus 11x minus 26 equals x minus 2, x plus 1a plus x plus 2, x plus 1b plus x plus 2, x minus 2c. So I would encourage you to pause the video real quick and make sure you understand how multiplying by the LCD gave me this expression down here. So moving along, we're going to solve for A, B, and C. And in order for us to do that, we're going to choose x values. And we're going to choose x values that would zero out any of these factors. And it would only be these three values that do that. X equals positive 2, x equals negative 1, and x equals negative 2. So at this point, I'm just going to take these three values and I'm going to plug them in for all of the x's in my equations up above. So I'll do each one, and that's going to allow me to determine A, B, and C. So if I use x equals 2, then I have 3 times 2 squared minus 11 times 2 minus 26 equals 2 minus 2, 2 plus 1, A, plus 2 plus 2, 2 plus 1, B, plus 2 plus 2, 2 minus 2, C. And so doing this, I'm going to end up with a 0 when I have 2 minus 2, which means the A term is going to go away. And the same thing occurs over in my C term. I again have a 2 minus 2, which turns to 0, so that goes away. So what I'm left with, 3 times 2 squared is 4, so I have 12 minus 22 minus 26 equals 0A. I don't need to write that. And then I have 2 plus 2, that is 4. 2 plus 1 is 3B. So I end up with negative 36 on the left equals 12B on the right, and dividing both sides by 12, I'm going to end up with negative 3. So I have my 1B value, and that's going to go, I'm going to scroll up here, into this equation at the top. So I still need to find A and C. So what I want to encourage you to do right now is pause. I'm going to pause the video, write out my solutions. You pause the video and make sure you can find A and C correctly. And so if you look here, you can see I found that C equals 4 and A equals 2. So I've got A equals 2, B is negative 3, and C is 4. So when I look at writing this out, I'm going to plug my A, B, and C values right in up here at the top of the page, and that's going to be my solution. So I'm going to go down to the bottom of my page and write that out. We have the original fraction is equal to 2, because that's my A value, over x plus 2, minus 3, notice there's a minus there, over x minus 2, and then plus 4 over x plus 1. So that is my partial fraction decomposition. And again, if you were to take these fractions and try to add them all together, getting common denominators, what you would end up with would be that original fraction where we started. Okay? So our final answer again down here.